This session is actually, I think, probably one of the most important of these 2 days. It's intended to be the capstone of these 2 days, where we bring it all together. As you know, because you've been here with us for a couple days, we have been discussing the hypotheses in groups, but now it's the time to bring them all together. And then we had some conversation about that this morning, so this is the time for that. And our approach to this session is that first, I will try to summarize what we heard this morning in our 3 hypothesis sections, and then Mike will run over an example of what an integrated research program might look like. And then we've invited these 4 gentlemen to the front because they are deeply involved in this. They can help us answer questions. Advisory panel members, this is your chance to mine the people who are here. We've assembled 90 brains, roughly, in this room. And so please, if you're in the advisory panel and there's something you need to know to do your work tomorrow, please let me know you want to speak and ask that question. Okay? That's what we're going to do. Okay, so my attempt to summarize the key points from the 3 hypothesis sections this morning. So predation, lots of interest in this topic. Actually, there's lots of interest in all 3. I thought we had really great discussions. The marine mammals, birds, we had a data gap, we don't know too much about that, and fish are important predators to look at. We do want to point out that there are a limited number of hypotheses that fit as well as predation to explain the decline of other instances of ground, so that's an important place to be looking. And you guys all agreed that this would be an important place for U.S.-Canada collaboration. So in disease, also some lively conversation there. Our panelists pointed out that salmon co-evolved with these diseases. So there seems to be some agreement in the room that disease is a contributing factor to salmon declines rather than perhaps a primary factor. But it's important to continue to study it and to watch out for new diseases or novel diseases that might come down the pipe or the street. And this is also a good place for U.S.-Canada collaboration. And then lastly, on habitat and toxics, I think Kurt made it pretty clear that the scale of habitat loss is large in the Salem Sea. Particularly, I guess we were talking about that down, but we heard that it's similar in Georgia. The unique level of toxics in the Salem Sea means that it likely plays a role in declines of salmon. But again, folks seem to think it was a contributing factor rather than a primary factor. So we'll see. And we do need to link habitat loss and toxics to the effects on fish, make that a little more clear for folks. And this is a very good place for U.S.-Canada collaboration, particularly since there is very little capacity remaining in Canada for work on contamination. So is there anything critical I missed in that summary? Sure. Part of the productivity.
Well, now, in this case, I think you have the detail that the sea has a secondary impact on forage fish.
Okay.
I would think we should
capture that. Okay. Lisa and I are taking that. Okay. Anything else that I missed that's critical? Okay. Then I will turn it over to Michael, who will give you an example of what an integrated research program could look like. We'll talk about the question of marine survival in the Salem Sea.
Okay, we talked about this a little bit. I thought it'd be good to give you a bit of a straw man to shoot at during this discussion. Of course, you don't have to shoot at this. You can shoot anywhere you want. But I thought we'd start going back to the conceptual framework or model. Again, lots of interpretations of what a model is, but this is where we started again to try to get at the idea of we're looking at this in an integrated fashion. So we saw it once. I'm not going to go over again what the factors are, but that's just again to show you we are thinking about this in the context of well, we did split out the factors to discuss it at the beginning. We thought about it as holistically. And this is just an example of an exercise I did. It's called a kanji model or diagram. It's basically like when you do your miles on your road map. There's a cross-reference from top to bottom, and it just shows basically how factors interrelate with one another. So it's a way you can kind of get at basically back-checking whatever you're proposing. for a hypothesis, and whatever activities you're proposing, you can cross-reference to make sure that the overlap is in appropriate places, that you're asking the right questions, and it's just kind of just a fundamental piece. Retrospective work, we talked about that earlier and the importance of it and the value, and I think, again, like we said this morning, that you can do retrospective work, but there's a lot of concerns about the data being fragmented. But we did still make the attempt to identify what you could do retrospectively in the report. A lot of times it was done from the perspective of past and future data combined, not just, we're going to do this retrospective analysis. We're going to use retrospective data plus some future monitoring and some sort of analysis that we're doing. So look in the report, and that should give you an idea. But what I really wanted to bring up was the monitoring component of what was proposed, and this is where you kind of see where a lot of these different activities are brought together. You did see the top table earlier in, I think, my presentation on the first day. And this is very small type. This is for Dave Preachot, who said that he saw a guy from FAO give a presentation in very small type, and I'm not going to read every line, so I'll save you that. This just basically lays out the different monitoring across different habitats, and starting basically from the freshwater through the estuary into the pelagic, the different measurement tools you could use, and then what you're going after. And it's a lot of what we talked about, from the individual population characteristics component, you're looking at survival abundance and density, behavior, size distribution, condition growth, and then spatial diversity. And there are footnotes here. One of the footnotes, obviously, was that you know the origin of the fish. So if you have to do some sort of mark identification or whatever you're doing to actually know the origin of the fish, that's important genetics. And then the second one is on the ecosystem impacts part. There is some things you're going to be doing looking at the fish to evaluate ecosystem impact, as well as looking at the environment. And I'll show you a table following this about what you're looking at in the environment. In this case, this is just toxics and harmful algae, where you would be looking for the extent and magnitude of the effect of exposure to toxics, and then you're looking for effect of harmful algae through gill scrapes, for example. And this is the last one for where you would be looking at the fish themselves through those fish monitoring activities, and this is diet and disease. And don't really have an exact estimation, but what I guess we're trying to show here is that you can pull this off in a cost-effective manner if you're trying to do everything, if you're trying to look across the board all at once, at least for the sampling end. The analysis that's a little different, but at least from the sampling end, if you're doing this as a group, there's some real cost savings in doing so. And of course, then that's simultaneous data collection, which seems like what everybody's trying to do. So here's the example of what you'd be looking at in the environment, water quality and harmful algae. Again, this is just a harmful algae presence, duration, intensity. Water quality would be trend monitoring network focused on spatial and temporal variability, all the way to primary production and then carbon chemistry. And then the community factors monitoring is where you get into the zooplankton tows. And all of this, of course, with the idea that they're all lined up with one another. So all the fish monitoring is in parallel with this by location, spatially, temporally. And so you have the net tows for zooplankton, then forage fish, herring component. That's where you're looking at prey, competition, and then possibly if forage fish are an indicator of survival. And then predation, this is at least the fish component. We're not showing some of the other ones that, like the hotspots analysis for steelhead, because that really doesn't categorically fall into this monitoring program. And then I just put the statement up there about the habitat component being that you just have to be rolling habitat in is be conscientious of where you're doing the work, have an understanding of the habitat where you're doing the work, so you can do that habitat association. And I'd say that's limited because Kurt brought in some definitely good points after we put this together, so that would have to be incorporated. But that's just an example. So.
Okay, so we've got we thought that what we would do is walk through some questions with you guys. You're ready. So the question. Okay. So the questions we wanted to go through with you are here on the screen. And what I'd like to do is attempt to actually go through them one by one if we can. We have actually quite a bit of time. We have almost, is that right? Yeah. So first off, for our general question, did you miss anything? Of the things that you heard yesterday and today, the hypotheses, the research recommendations, is there anything critical that now that you've got through the whole thing that you think we're Lori. Okay.
I think one thing that didn't really come up at all, but is what can we as humans do to increase survival? Realistically, I mean, you obviously can't change the weather, can't change tidal mixing, and I think in thinking about what the plan ought to be is what things do we have control over, and how does that play into it?
Okay, so what management has of access to it? Yeah. Yes.
Let's stop for a minute.
Let's stop there.
Because we're going to waste time if we just put together another long list. Why don't we stop at that and see if people can discuss and take a few minutes to see what humans can do? What are your ideas?
Okay. We can do that. What are your ideas? What can humans do? Here's some ideas.
Variable changes in hatchery release production based on measurement real time of productivity in the stainless steel industry.
Okay. Others, Mike and then Bill, and then if you can do your thing. Yeah, Mike and Bill.
I think that's the wrong approach right off the bat, because if 97% of the problem is something else, then to waste your time on that 3% that you can do. Even if we can't do anything about some environmental problem, doesn't mean that we can't face reality and understand what the problem is and explain that to people and manage for that, forecast for that, et cetera, et cetera. So I think it's the wrong approach to just automatically go, oh, we can't do anything about it, so let's focus on what we can do. That's not going to get us where we need to go.
Okay. So the constants are there. We have Bill, Sonia, Stuart, Alan, and Court. Bill's next.
Well, I like that first idea myself, and we're always talking raising things by a percent. I mean, literally, if they're mostly going to die, absolutely. What do you want to have 1% come back on the system? That's the way to start. Maybe 2% if we're lucky. We're talking little incremental differences in return, and if they're always positive, we made an impact. So that's kind of my view. I mean, I agree that so a lot of those fish dying in a few days. And I don't know what to do about that. Make sure the hatcheries release only healthy fish.
That was the one you had to put, right?
Okay, I like the idea as well. I think we should use what we didn't have in the process of testing. We're doing that in our area, so we're looking at Gabriel's being an issue in hatchery beard fish in coho. So we're actually looking at doing vaccination on the population. We're marking all the fish with code wire tag. We're doing control and experimental fish. We're releasing them. We're doing it over a 3-year period, 3 to 5 years, so we can actually see annual variation. And we're going to hopefully meet up by 2 weekends to set a return. We're also looking at moving the whole ecosystem. We're also looking at zooplankton and phytoplankton in the immediate area outside of the river system. We're monitoring it starting in February to June. We're doing deep staining and systemic content. And we're also doing fish health monitoring of the fish. We think that BCE is an important issue. So a lot of the BC facilities haven't really been monitoring the BCE. So we're looking at monitoring the broodstock and the terms come back, getting a baseline. It does look like an issue, then we're going to try to manage around it. And we're also doing pre-vaccination and pre-release fish health checks just to see if there's any kind of fish health concerns. And then we just do that over 2 years and monitor. Okay. Great. And the next one,
one of the things that I have to say here is the whole question of aid quality. Aid quality.
Aid quality.
Yeah. So, I think there's good evidence from the Atlantic salmon that when fish are stressed upon their return migration, the quality of the race suffers, which probably has an effect on the quality of the offspring. And it's something that we could maybe do something about. If river temperatures and something that we by modifying river flows and more habitat along the riverbank. So it's one area that no one's really touched on. And it's probably, it sets these fish on, they can direct their lives.
Yeah, I guess I would look at rephrasing the first point you make up there. How much of this is need to know and how much of it's nice to know information? Is there a way to focus in a little bit more directly on what the brain power in this room thinks is the most likely cause of the problem, and then focus on that? Because just the monitoring, which is all well and good, we have to monitor everywhere all the time. I prefer to monitor my area, but people like to monitor their area. How can we get to the most efficient use of scarce resources?
If people want to say that they think it's important, that would be Corey and then Dave and then Rusty and then
following up on the list of things we can do, I would add estuary and shoreline restoration.
Okay.
And thinking about it from the Pacific Cascade perspective, I think there might be game depend on changes in nutrient input.
Okay. Everyone hear that? Shoreline modification, changes in nutrient. Okay. And Rupert. Okay. Dave is next, and Rusty, then Ed, and Kirk, and Rupert. And then
Yeah, I agree with, and I want to amplify what Alan was saying, because I think that's important. And I think the way I might amplify it is to say, in any one of the recommendations we make, there's two types of things. There's monitoring things, which is just keep track of stuff, and maybe the question that was trying to be raised here is what are the proactive things rather than the reactive things. And those proactive things, we as scientists have to do a better job of saying what's the payoff, which is what Alan was talking about. And so we have to come, and maybe that's why some pilot projects are good, because, there is this talk about estuary stuff, but the payoff, if you want to really get involved in doing estuary rehabilitation, as Brian was talking about, the city of Vancouver, is economic trade-offs that would just be unacceptable. Now, it may turn out that some of those projects may actually have a decent payoff for local areas, but we have to do a more honest job of saying what the trade-offs are in terms of bang for buck, so that people can have a way of measuring whether or not this was giving them some kind of value for money, and especially in the fiscal environment that all of us are trying to operate within. It's going to be impossible to operate without that in the future. So I think that has to characterize these things about the proactive things, is what are we going to get at, or how do we at least begin to design projects that are going to help define that.
Okay, a couple of comments. First of all, to what Dave just said, there is a problem with that with monitoring programs because it's part of the state representative practice. Yeah, no, I know, but you're also trying to collect data.
But my point was, and the question has been asked several times in the past 2 days, we haven't got an answer yet, what kills fish in the ocean? There's no video around it. Let's hope that nobody thinks that we have no idea what kills fish.
Really, really close?
I mean, it's easy to say, okay, it's predation and disease, but the other side is we heard everybody saying, well, there's probably food limitation and there's competition, right? Different sized fish are going to have different causes of death and mortality, right? So, I mean, it's not a simple answer in any sense. I think the reason that you really have to consider major changes, and Buzz talked about it last night, in very complicated systems with lots of noise, you need big changes to see effect. Right? So actually, unfortunately, jump out as an obvious place where you can do experimentation and that. Maybe the sport guys aren't going to like this anymore. I actually doubt that very, very much. I think people are prepared to make big changes because we're not really going anywhere. We're not seeing things by just measuring stuff. Right? So you got to get the monitoring out there, and then you got to make these changes. And I think Tony, I think, is talking about changes, not changes so much as how you manage the hatching. So in the production of ducks, put them in multiple lines, treat them in different ways, make sure they're tagged. Another question I think we got to check with ourselves, and on Canada the answer is no to this. Do we have sufficient assessment information on the species of interest that we can really measure these effects? Right now, I would think the answer is no. We're down to such bare bones that we're going to have to put money into basic fundamental monitoring. So I don't think we should ask ourselves or think that it's silly that we can't answer that question. It's not that simple. It's going to change every year. That's why we tell people to forget about going out and picking your favorite topic and measuring all the interactions. You got to take it apart. So, I mean, I think we've got to step back maybe and ask ourselves, if you like that approach and a methodology, can we buy into what the key components are? And one of those, to me, really is we've got to really decide, is there sufficient benefits in taking on a collaborative international program that merits that? And it's not going to be trivial, right? So what do we gain by including everybody? I mean, I think it makes good common sense, and there's power in having more replication and all the rest. But every area is going to be a little bit different, so some people aren't going to buy into that.
Other responses from the panel? Okay,
I'm Ed Stewart. I had a few comments on my experience at the 10,000 foot level that I think would be helpful here. I was involved in setting up an ecosystem assessment program that Phil Peterson just described as the program manager. At the time that we set that program up, about $3 billion had to be spent under the system to recover about 13 stocks of invasive species of salmon. And during that $3 billion, a lot of money spent, but not much to show for it in terms of recovery of endangered species remains. And the big elephant in the room that everyone assumed that by the end of the 90s was that we didn't know what was going on in the ocean. So the program was begun to do install a program very much like the being proposed here on the northwest coast. Over the 13 years which I managed the program to follow and execute that program, we spent an order of magnitude more money than what's being managed out here. And so the cost of a program of the size that you're envisioning and talking about is going to be, in my estimation, far greater than the source of money that you're proposing at this time. So that's one thing that's going to cost a lot more money than you think to do the kind of work that we've been undertaking. Secondly, the time frame that our folks started appreciating the value of the information we were generating, because we're doing both bottom-up, top-down physical, biological oceanography, relating this to large-scale foresting. The time frame in which we started appreciating our ability to start making inferences that we believed in was probably on the order of 10 years. So, again, the time frame that you are talking about to do this assessment at the integrated level that you're working at, that is not going to be long enough to be able to make inferences that you envision that you want to make. So that's from the scientist level. Our appreciation of data really didn't become current until after about 10 years of collecting information. We all believed in it, but it started making sense after about 10 years. And part of that is because, in the end, most of us are relating information to a single year return rate, a single number. So you compress all that data and relating it to an actual return of another data point. So it's very hard to make inferences on 5 years of data, one data point each year, or whatever metrics you're assessing. And then trying to put that in this integrated assessment. It's very hard. So I think 10 years is the minimum time frame something needs to be thinking about. So one of the things that we recognized when we started in 98 with this program is that we don't have a time frame. So one of the surveys that a number of us recognized was to relate the time series by not having time series was to actually expand the spatial coverage in our assessment. And so we installed and implemented the workshop with all researchers on the West Coast. So we brought in the Alaska folks, the Canadian folks, ourselves, and California researchers to have a workshop which we installed in 98 and have done that every year since to share our findings and to tell each other how we can acquire information spatially on a similar pathway so that we're all doing the same thing, tracking just the same way, trying to do the same type of information so that we didn't have to rely exclusively on time series because we were looking for the signal to noise ratio of the response damage and variation in ecosystems. So we did that spatially. So to recommend to this point here is to plug into that effort because it's ongoing now. The workshop is ongoing. Mark said that this year's effort is going to be in the North Pacific National Fish Commission meeting in Hawaii. Is that correct, Mark? So I would encourage people here, if they're really interested in trying to figure out what other people are doing, and they're trying to do the same thing that they're trying to envision here, to go to that workshop in Hawaii in April.
Yes, we'll all go.
We had trouble getting the billing here.
Yeah, I know. But a lot of people have been working on this since 98 when we brought people together, so lessons learned can be greatly appreciated from going to this workshop where people are doing the same thing. From this effort, I think there is a clear help or a view that the bottom-up processes were really the particular driver of the success of salmon. You've heard that here a number of times. And so the question becomes, if we have limited resources and limited amount of time, most of the information we have really focuses on the bottom-up. The relationship between the large-scale forces that influence the local-scale dynamics of the system and how salmon relate to that in terms of the growth patterns that you see. And that's evident in California, evident in the Northwest Coast, evident off Canada, and evident in Alaska, with a variety of different species. So if we're looking at that, the focus may not be seen on the broad-scale ecosystem approach, but to really target on the growth side of the ecosystem. And then finally, in terms of policy, or trying to get information into policy, which I have experience in NOAA, set the policy through the regional office and how the people use the environment with respect to fisheries. And so the Science Center produced that information for policy studies. So we were deeply involved in thinking about policy, sort of on a planetary refer to that. But the bar of information is quite different to influence policy than the bar that you would use to publish information in scientific journals. And as Brett Holland, I think, was talked about last night, that's really what we want to do. And we have proposed that, similar to other talk here, the focus of policy that we were centering on was actually hatchery fish. In the Columbia, we have third level of hatchery production. And the large-scale experiments that we wanted to conduct was of the nature of when the ocean was full, and the effort was to save wild salmon, which is what we just gave for us today. Those are years that we were going to start beginning to suggest that you would not release the hatchery fish into the system. As the large experiment to see if in fact that would make an incredibly lot better. Well, the pushback and the anger from all those people to suggest that we would tell hatcheries at this legislative tiers to get those fish ready and say you can't release them, that wasn't going to happen. I think an act of God would be needed to affect that. But as someone suggested earlier this morning, I think if you're going to employ the policy, recognize the bar is higher, and you have to bring those people into play a lot sooner than you think. And that's the issue. We also have, for instance, one of the effects release of steelhead into the plume. And the plume, we have evidence that suggests that the plume size is very critical to the steelhead survival. So a larger plume that was heading south out of the Columbia system was beneficial to steelhead survival. The board says very clearly. Again, the question is, can we suggest to release salmon, and we had a model to predict when the plume would be available to be appropriate for them, 7 days in advance of the possibility. Again, to do that, we have God to get people to release it. To make that large-scale test. The policy issues are something, in addition to the science that you use to publish. That policy means greater, I think, a greater bar of understanding and greater ability to influence people. One of the most important points is to bring them in early and plan on a number of years' effort to get them to start instituting the potential large-scale test that you want to demonstrate the understanding of safety.
Great. That was a lot. Funding is important. Time is serious. We need probably more than 5 years, more like 10. Vehicles, diversity is good. What?
Minimum 10.
Minimum 10. Coordination is important. Look for collaboration with others. Maybe we don't go to Hawaii next time. Bottom-up processes are important. Look at growth. And there's a high bar for the state and the community to change policy or influence policy. Did we get that?
And just to note, advisory panel members, we have one tomorrow. So focus on questions, please, to get what you need for tomorrow. And you're definitely going to be the voice of this larger panel or larger group. So thank you.
Okay. Kurt is next. And then Rupert, and then Hans, and then Andy. Am I missing anyone? And Kurt. And Kurt. Okay. Remember, we were talking about what management actions can we take. That was a question a long time ago, and then we had Kurt.
So this is just a question. Since my brain has a hard time compiling all this information, it struck me that it would really be nice to see a summary of sort of going on Ian Perry's sort of 3 things. What do we really know? I mean, do we really know that all populations of Chinook and Coho and the Salish Sea have crashed? Is it some? So some sort of systematic compilation of that. And, you know, because one of the things that struck me yesterday was, you know, the fish people are waiting for the oceanographers to say something about what happened in 1989, and maybe they don't have any data about 1989. So it would be good to, I think, you know, maybe as a product of the workshop, be able to summarize those sorts of what we know and really what we, major things that we don't know. And a lot of those were mentioned. And like I said, I'm having a hard time sort of getting my brain around all of them.
Okay. Fair point. Very specific for you.
I'm just looking for
No, you're just looking for it. Okay. Hans.
Okay. So, I guess this is a smaller scale project, but within the context that Ed put out there, that that sort of these longer time frames are going to be necessary to accomplish sort of the goals that we're looking for. A resource or a tool that I would really like to see that I think could be accomplished within the monetary scale that we're dealing with. To expand on the data center idea that we have back here, and to include a resource for standardized methods and protocols that groups, I was, for example, contract, and the research that I do is generally directed at kind of answering smaller scale questions, but we do a lot of monitoring that if the data, if there was a standardized method and protocol resource out there, I could frame our research project within that and essentially be able to bring something useful to the broader regional scale.
Okay. Good point.
And then the only other thing, as it is, in the 1990s, the one thing that we haven't really talked about much is kind of the massive explosion in population in the region. Of people and impervious surface.
All right. Andy.
In Southtown, up till the 1990s, the NOAA, the Dept master program, were doing very well, high marine survival rate, and that started to go down dramatically. And as that went down, what went up was the return of chum to Southtown. Those chum were all wild fish. 10 years later, there was a population explosion in the Puyallup River and the Green River of pink salmon. Where previously there was just some remnant token pink salmon around, now we're seeing millions of fish returning to each one of those rivers. So in Southtown, there was a flip. Now this flip, well, going along what Kurt said, in different regions, we're going to see different responses to different species. But I just want to emphasize that we should not focus only on coho and chinook. That what's happening to other populations, including things like squid, are part of this puzzle.
This is building on, this is one that I have to go with. It's building on what you just said there, and it's kind of on point 4. So, there's some signals out there that we have to take into account. Pink salmon, the state of Georgia, is also doing well in chum salmon, and lake ocean entry Chinook salmon. So when we're looking at hypotheses, it has to fit. You can't say something's only affecting one small group of fish if they're all in the strait or in the region at the same time. So it helps us narrow down what the factors will be and what could be causing at the time. And in 2012, apparently the returns of coho to the upper Fraser have rebounded and are doing well, and the late open entry Chinook salmon have not done well. So these fish that have been, for the last 5 or 6 years, have been a good component of our Chinook returns. So let's go back and take a look at the open entry for those two. There'll be different open entry years. And what conditions were those fish experiencing at that time? And can we narrow down if there's some other fish that entered the ocean that year that may have undergone similar good or poor survival? In addition, I know for our survey, we're out there in the middle of July when a lot of the mortality has already occurred. So if we need to look in the first 4 weeks, what does that sampling look like? How do we sample in the near-shore areas? And what do we sample so that we're getting a representative cross-section of the population?
Great. Okay, I've got Parker and Josh doing research, and I'd like to suggest that maybe we move to the next question about is there enough information to develop a model?
In terms of experimental
designed to answer the question about what's killing the fish. One approach would be really narrow the focus to the population that you know dies quickly, that is, has known to have rapid losses, in a place that's very geographically confined, like Beauchamp, for example. And that avoids a lot of problems of experimental error because you know the fish are only there. They can only go. There's only one path out from the sea, so it's easier to focus enough effort. You can really decide well that population will take that.
Great. All right, Josh, and then
yeah, so I want to respond to the first question and also something that Ed said. Ed made the comment that it looked like we were bottom-up projects were doing the driver's seat here. And I guess the way I would want to answer that first question or think about it is instead of doing this anything important, have we included anything that isn't important? And what can we start to eliminate in the same way, you know, I think the same as the workshop, so we can say some extra stuff here and not feel bad about it. In the same way that it was mentioned earlier, can we focus on studying processes that will result in management actions that we could take? I mean, so for steelhead, for example, I might say that was an exception to that comment. I didn't see any evidence that bottom-up processes are controlling steelhead in the state of the sea. In fact, I saw really only an argument for one process controlling steelhead, and that was predation. I mean, is that a fair? Does the group of people here see the same thing I did, and can we say that that is a fair hypothesis to be operating on now in that case? And in addition to that, when we talk about models, I think queuing this information, the information that was generated by the technical folks before this that had hypothesis articulated, we just saw a very cursory example of that, probably has enough information to put into a model to answer those questions. What can we eliminate? And how can we focus our actions on manageable tasks later, or understanding things that are manageable later?
Okay. So I think let's let Richard make his point, and then let's turn to Josh's question about if we include anything here that isn't important, so we can.
I'm just going to throw this out here as another idea for what can we do, and maybe it's because I'm coming from an observatory or a monitoring type of perspective, but maybe some of the things that can come out of this initiative aren't a 3-year experiment, but have some legacy. And an idea that might come to mind is make sure everyone who's collecting yearling or sub-yearling fish has the ability to do a listed assessment. So that across the board we start collecting that data, not for 3 years, but for 20 years, and get a long-term legacy out of a program like this. So maybe it won't be very sexy, but it may be very helpful in the long term.
Okay, so Jocelyn, we're asked. We're going to throw out. So Harry and then Nate.
Well, this isn't exactly what we can throw out, but the comment you made about steelhead predation. One of the things I've been talking to some of our people about in terms of research teams is with steelhead, we know we have a changing glacier system, for especially the high elevation spawning steelhead. We know we're losing the glaciers fairly quickly, and the hydrology is changing. We also know that the hydrology of the forest landscape has changed fairly dramatically. And then our spring flows are coming too 3 months early, and then we have a big drought. So we've got an early flood and long drought. The thing that I'm looking for in the research is how has that hydrology changed? Is it shrinking the habitat that the steelhead had to spawn and rear in the higher elevations? And is that one of the problems? And then I think I had placed this in front of the Chief South Partnership to see if they can move their research to at least examining part of that as part of the steelhead issue. But to me, I think there's obviously some predation problems, but I think we have a bigger problem in hydrology and temperature.
No, I'm not going to help you narrow it. I was actually thinking some of the same things that I think Terry's bringing up, that there's good evidence that the multiple adult return rates for steelhead in the Salish Sea have been very low in recent decades. But for the wild stock, the freshwater habitat is still critical, and we have had some really extreme stream flow years with near record low flows in September and October, followed by 100-year floods the next week. And those kind of hydrologic extremes compressed into a really short window of time are terrible for fish that are rearing for a year or two in those systems. You put that on top of the degradation in the watersheds that has accumulated over a century, and that has really reduced their potential for the freshwater productivity. So, we've talked a lot about the marine system here, but for the wild stock, habitat on the freshwater side and in the estuaries is probably the biggest driver of decline over the longer period that we're just sort of accepting. It seems like in this meeting we're just sort of taking it as a given.
All right. Anyone else want to, Mike? Oh, Brian wants to talk. Brian, you want to talk?
No. I can go ahead. I'll ask after. I have a question that just came to mind. I'm following up.
Oh, okay. All right.
So, my understanding was the objective of this, at least when we put our research plan together, was to develop primary factors, a list of primary factors that we thought were affecting the survival of salmon and steelhead in the Salish Sea. And we didn't say that we knew all that, and we came here with all the answers, but what we said is we would come here to develop a plan to figure out what those primary factors were. And so, my experience in doing other, like, limiting factor studies is if you don't collect the right data simultaneously when you have the opportunity, you can get maybe an indicator, or maybe you can get a result without an indicator, and in the end you don't get the full picture that you could have had when you had that opportunity. And it occurs early on in another effort trying to improve our ability to forecast for management purposes and for salmon recovery purposes, that these environmental conditions are changing rapidly, and there's a persistent decline, but also this variability and abundance is really causing havoc in our ability to manage. And so it is obvious that there are already ongoing efforts here, and that we need to coordinate with our Canadian partners in order to get this work done. But to develop like a Bill Pearson style forecasting method that incorporates environmental variables, incorporates plankton, which is, that's one of the first things I heard when I talked to Canadian counterparts and other people in the United States. We don't have the adequate sampling that's not been in place. And that should be concurrently collected with juvenile fish sampling, bait fish, and these physical atmospheric monitoring that needs to occur at the same time. And I heard it over and over and over again, and I see it in the plan. And, your fourth bullet on there is what can be done iteratively and, to improve cost effectiveness. Well, you're going to improve on this over time as you learn more, but you're going to be able to knock a whole bunch of birds off with one stone when you're collecting. You're going to kill a fish, sample it for everything that everybody needs, and systematically, collaboratively develop methods so we don't waste time or do things that we can't replicate, and agree to exchange and share data. I thought we were going to come out, if we spelled out a plan that has a specific monitoring plan. We already played around with this a little bit. It's not that expensive. It's not that impossible to do. You can figure out how many times per month you're going to collect what types of samples and what they cost to analyze. Throw in your boat costs. With all the different agencies and countries that are involved here, it isn't that much. It's not going to be that impossible to do, and we're already doing it. It's just not a good enough fragmented job that it's not getting done. So, and in the end, yes, it might be a bottom-up process that's driving a lot of the problem, but That is, we need that for forecasting and management. We need it to understand what the problem is in order to get our goal, our objective. So, that's all I have to say.
Well, the question that came to mind, and I shouldn't even ask you because I don't work in steelhead, but is there any direct comparison of hatchery and wild tagging to look at the survival rate of hatchery and wild fish in the same group? And the answer is?
The answer is yes, and the answer is that it's variable. It depends on the hatchery. And what I've seen in the literature and what we've seen from our recent tagging studies is that there's more variability in the survivability of hatchery fish among hatcheries than there is among natural populations. And to lead in the point that was made earlier about the upstream effects, in Hood Canal we have the opportunity to look at steelhead out-migrating from lowland range-river systems and from transitional systems. We can see the effects of temperature on out-migration timing, and we don't see a real strong effect of out-migration timing or body size on early marine survival. So we may not have the power to detect it. But we also see very consistent results from year to year, fairly consistent results. And where we see the biggest difference is in the survivability of fish raised at different hatcheries, even though the wild population exhibit similar survival rates. And I think that that's the point that's often missed, is that we tend to use hatcheries when we see an anomaly that's up. A graph earlier today where the hatchery timing was this and something else was that. That could very likely be an artifact of the hatchery and an unintended artifact of the hatchery. So I think the answer is that the survivals that we've seen can be about the same as wild fish or less, but we haven't seen them be greater.
Can you answer the question about
so all we have to go, all that I'm aware of in terms of what's impacting steelhead are, the evidence suggests that there are top-down processes just because of the rapidity with which they leave the system. But I was talking with Kip earlier, and he brought up a good point based on some of the information that he laid out yesterday, which was, all right, the fish used to stay a while, and now they're gone early, if I got that right. And so how do we not know that that's not the case for steelhead, that maybe steelhead stuck around in the mid-1980s a little bit longer, another week or 2 weeks or 3 weeks. And it's just an artifact of the current conditions that they're leaving very rapidly. I suspect that's not the case, but it's certainly possible, and I don't think we know the answer to that.
All right. I have Zach and then Dave and then Bill.
Yeah, I'm not compelled to say what I was going to say, but I just want to make a note that I might ask if there's another reason that steelhead are dying in the marine environment, and we got two very well-reasoned comments about why freshwater habitat may not be supporting them, and I think that's a message that should come out of it. We should say, hey, well, maybe there isn't a lot of reasons in the marine environment, but clearly there's some concerns about freshwater, and we shouldn't let that go. But editorial comment, we have spent a good amount of money and will continue to spend a good amount of money on freshwater habitat protection and recovery, and we're a little bit behind in this arena. So we're trying to focus. So my question back to folks, and I think maybe it sounds to me like, let me paraphrase what you said, Barry, and that is we have some evidence that there's a lot of variability within hatchery steelhead that leave the system. There is evidence that there is some evidence that predation may be a controlling factor, and there is some speculation that maybe they used to behave differently previously, but now they're going straight out of the system and some of their form of mortality is up. I guess I'm trying to give us a model to start shrinking our search pattern so we can come up with a research plan by the end of tomorrow for steelhead, Chinook, and cobalt. So yeah, I think I don't know if there's even speculation that it was. I think it's worth raising the question whether or not the steelhead migratory patterns to the early marine phase were different than they are now. It was just that we simply don't know. And I think that it is important for us to, unless somebody has some advice or information, we'd love to hear it.
that really looks like we've got different drivers for steelhead than we do for coho and chinook. And I think we need to be, as we move forward in this whole thing, looking at them differently.
James, do you want to add to that? Yeah.
You recall that some of the trends that we were showing were depressions over time in the smolt to adult survival rate. So that eliminates, or presumably eliminates, some of those freshwater conditions. Yes, you can have depression in the freshwater phase that affects the population overall, but when you're talking about smolt to adult survival, we really are trying to talk about what's happening out in the marine environment there. Suggestion is it's the top aspect.
Yeah. Okay. All right. I had Dave and then Bill and then Ed and let's go one more stuff. Dave.
Okay, on the issue of top-down objectives to was raised for, I don't think I need that. So on the issue of top-down stuff, there's a big problem. And a lot of my friends and colleagues who work in the terrestrial environment have been involved in projects where they exclude elk and caribou in certain places, where they add wolves and grizzlies to other places, and they move around predator and prey systems like that. So much controversy, but they do have some expectation of what the feedback are likely to be, what the trade-offs are. Now, it was pointed out by Ken earlier today that if we suggested nearly something like that with harvest bills, it would be likely met with a certain degree of consternation and even outright opposition by the society at large. But one of the things which might be valuable to come out of the monitoring project is more informed statements about it's not direct predation of get rid of seals and we're going to grow more stuff, but competition effect. Maybe there is a trade-off to be made by waxing hay. You know, this is by doing that, maybe there's a more acceptable policy there. But these are things which have been ongoing in the terrestrial environment and have been done. So I think we have to be more willing to entertain these sorts of manipulations as options.
All right, Bill, next.
Yeah, next is steelhead. They're really intriguing, and I'm a copperfog guy, because they're interesting animals. They're different from the other animals. They're really different. And just to remind you what Lori mentioned a little while ago, is the steelhead come to the ocean, to the coastal ocean. They pass through that zone as fast as they can. They're heading for the blue water, I don't know why, but they do not like the coastal zone. There's something about it. Maybe they know something that we don't know. The place is going to get eaten. But they don't spend any time in sharp water. And I find that just absolutely amazing. And you go there with a foot over it. Where are they going? What are they doing out there? I have no idea.
Eat squid?
Yeah, maybe. But other countries, I'm hearing from the sheriff and they want to go to the high altitudes to spawn, then get down to the open ocean to live. What an amazing way to pull off your life. Or to try to pull off your life.
All right.
Additional comments. One thing is from my experience over the 30 years as a fish biologist, I think basically all fish are eaten. Those are basically not try and push it about whether it's good or not. It doesn't necessarily mean that you should focus on predation, though, and as a factor to try the outcome. It's still something related to the productivity of systems, the ability of the animals to our food, which affects their ability to how often they look for food relative to other things. So, food and focusing on predation, especially is the same thing. The bottom-up process still takes a lot of what's going on. When I refer to the bottom-up process, though, in in terms of the evidence that we were doing and agricultural approach around Canada, California, Washington, where it was really driven by that information relative to challenge 8 Chinook code, not field. So, and as Bill alluded to, field that was moving into our system was very identified that they're moving through systems very fast. But in our system in Colombia, they're moving too fast. But they are going to the plain structures and they find them at certain spots. And they've identified them that they concentrate there at that region. That is the region where the birds are hanging out. That is the region where all the marine animals are hanging out. And it's a different geodynamic area where those concentrations do resources occurs. They're hanging out there and they're gone. And that's where the application takes effect. For them there, we don't know. But in terms of customers growth for steelhead, we don't have that information. But we do know that the structure of the environment we're in is very important. That's pretty much what I wanted to say.
Okay, great. Yeah.
I was going to say, I talked quite a bit about that, about the sublethal effects of, say, low food availability or, immunocompetence on predation. I agree with you. I think that ultimately, nearly all of these fish get eaten before they die, right? And so, what's affecting them? I think for steelhead, it's possible that, low food abundance at particular times could cause them to search more because they kind of foraging predation risk, trade-off type theory, you can look at that, but they really do seem to be moving kind of down the open water in Hood Canal and Puget Sound, moving out fairly rapidly. It's possible that something like that's going on. So far, we don't have any indication of that, so if anybody has that too.
All right. Who's next? And then Mara, and then Nate.
I guess, I'm not a scientist, so sitting through all these presentations and it's kind of a mind-boggling collection of possibilities. But I guess in thinking about, some of the discussion in the last half hour or so, we've got this trend that's been identified that seems common throughout the Salmon Sea. And there's a number of things, habitat or contaminants or things that could, potentially shift that trend line up. But they're not going to change the trajectory of that trend line. But the ecosystem side of things, which is, I guess, why we came here, sort of the big question, the bottom up, or however you describe it. I think the intent of trying to solve that is to change that trajectory. So I'm just wondering if it's worth trying to separate things out on a basis like that, and it might sort of clarify where we go.
The basis being, are we shifting the trend or are we changing the
Yeah, so are the variables or the hypotheses we discussed things that are going to shift the trend line up or down slightly, or are they going to actually be fundamental and change the trajectory of the trend?
It's a little bit like the question that was posed to us when we came up with our program, and we're told to fix it. Because, you can take a number of the ecosystem groups together. So what's big enough to make a change? Okay, herring. So the common sense thought is stop fishing. Right? We haven't fished over 20%. We probably haven't fished over 10% in the last decade. And the population is still going down. Right? And we're losing the spawning place. So it's not just the abundance. We probably have to do a few global things. See if we can reestablish herring in some areas. The other one is hake. Comes up all the time. Right? One of the comments to us was, well, you should fish out hake. Right? People aren't going to like that. It's not going to be easy to do. And if shields and others are feeding on hake, why not maximize hake? Is it better to have shields getting off salmon because they have readily available hake?
Right? So, I mean, until we understand some of these dynamics, we're guessing at what the study should actually be. If you could actually stop area fishing for 5 years or something and look at the results, that's not a big economic cost anymore. The market value of herring roe is very depressed. You might be able to do stuff like that now in the Strait of Georgia. So maybe that's one we could take on. That really is an ecosystem study. After that, what would you do? Stop deposit fishing? That's pretty valuable. Maybe we'll have trouble with that one. But maybe you could do it in certain areas. Maybe you could take them out of house now. See if there's an effect on that. I mean, we can use some of the areas for different types of studies. But and it's true that we should look at these big changes. Some of them are not going to be immediately obvious what to do.
So, my one thought here in terms of cost effectiveness, and it has been mentioned, but I just wanted to highlight, is that where we can set up comparisons of high and low rate survival, I think we'll get the biggest bang for our buck, and that is looking at the populations that are already depressed and trying to develop a time series. And so one of the things that Corey and I had started with was a suggestion that we focus spatially on areas at least in the U.S. Portion of the Salmon Sea, where we have existing juvenile adult monitoring, where we can couple all the ecosystem information about productivity, about zooplankton and forage fish to the freshwater marine survival of those populations. So that comparison across the Salmon Sea, I think, being really important, and I think that we'll find that it's not as homogeneous as is being discussed here, at least for the U.S. population. I'm not familiar with the Canadian population, so I can speak there. And the other is that we have these two species, chum and pink salmon, that are not showing the same trends as some of these other species. There's a lot of information to be gained. Why are they doing so? Or why are they doing well? Or why are they doing well in some areas where other populations are not? And so I think those comparisons are really valuable and cost effective here. And then my last point, it actually has to do with the freshwater contributions. This research plan is very much focused on marine survival. However, the condition of the smoke coming into the Salmon Sea sets them up for survival in the marine environment. And so if we have density-dependent effects in freshwater, we have habitat issues in freshwater. If the fish is growing at different rates in freshwater, all of these set up the fish for success within the Salmon Sea. And to me, that's the most important piece that we don't want to forget about the freshwater contributions when considering this research plan.
That's one thing that I was thinking about that we didn't talk very much about the last few days was the net 10 programs that exist in Puget Sound have this alternative rearing strategy for hatchery fish. They hold on to them for delayed release with the expectation that might keep them in the sound better than fisheries. We have some pretty good data on the rate survival rates for those stocks to compare with the traditional hatchery program. In the last decade or so, their performance has been equally horrible. That you're growing fish to a pretty large size, releasing them after that early marine period that the traditional hatchery program those fish are experiencing, and their survival is about the same or worse. So that suggests that maybe it isn't all happening in that late spring or summer early marine period for those stocks. So maybe it's because there's just a group of predators trained on those programs, I don't know. But they're not producing a lot of fish. So I think that's another interesting kind of comparison, alternative rearing strategies that exist. There might be some data that is there that can improve the understanding.
Great, thanks. Dick, do you want to respond to that?
Just a comment that I haven't made. I think that we have mentioned that the Great Ocean entry should not. That's been mentioned, and I think
probably mentioned there is some Chinook entry in the Strait of Berejikian. But look, these guys are entering the strait when the water is warmer and the salinity is less. So they're entering an environment that we normally would not think would be suitable for salmon. And that's what's dry. So now you're coming along and mention the next thing that sort of knew that. And I think that that's information that actually fits when we're trying to understand what's going on. We need to incorporate that kind of information. I don't know if fish not doing so well. There's something that's going on. And like the salmon enter an environment that we normally think is stressful, high temperature, low salinity, and maybe extremely that.
So I got Sophie and then Jim. And then I'd like to just sort of take a collective temperature, possibly salinity, and find out what, have we exhausted this question, and can we move on to the model? So be thinking about that. See if we can move on to the model. So,
I was actually trying to move on to number 3.
Oh, you can
Okay,
take that.
good,
That's
yeah,
fine.
please.
I was suggesting for a way to organize the activities into groups, 4 groups that could be done simultaneously. The first group would be retrospective work along the lines of Chris Neville suggesting to us with this, where we put together the fishery records and look at particular dives and particular good times and places and ask the oceanographic data that we do have what those years are like. The second part is about fish conditions, leaving rivers and leaving the Strait of Georgia related to the dead fish swimming area. And that would be a place to fit in disease and contaminant and energy and size of the fish. And that could include historical data and some field work. A third part, and probably the biggest part, would be on early marine survival, since that seems to be the hypothesis that most people are leaning towards, and that would be where we could fit in most of the field work: sediment traps, dosite controls, satellite data, juvenile fish surveys, temperature and salinity, time for algal blooms, early predation, and the hatchery manipulation, and then link all that with eventual returns. And then the fourth part would be on predation, and I don't know what activities to suggest for.
Hello? Yeah. The hypothesis that predation on steelhead by seals is certainly appealing to me, and that you can have a relatively easy story to tell if the seals even steelhead and the seal population has run amok. So it's an appealing hypothesis to me. In some ways, it's also my worst fear, having been engaged in litigation on the Columbia River over sea line removal during the last 3 years, and receiving over 7,000 emails for removal of wolves in northeastern Washington. So that's some good points and some bad points. But from a more science perspective, I'm skeptical now, I'd have to say, and for several reasons. One of those is the similarity of the timing and decline of survival rate for Chinook, coho, and steelhead suggests to me that it's likely that there is some common phenomena affecting all of them. It's just too severe. Second, the synchrony with the major changes in oceanic conditions, I think, is also striking to me. And as Ian did his analysis of what's happening in Georgia Strait for Chinook, certainly that was one of the things that popped out. In the information that was presented on the diet of seals, I guess I'm not a seal expert by any way, stretch of the imagination. But I saw I think it was the San Juan was the information that had diet information during the winter and spring period. And I didn't see in that any indication that they were feeding on juvenile steelhead or salmon in general. Certainly there's no doubt in all of our minds that they're eating adult salmon, steelhead, that's a different question than the juvenile. The other point that was Nate just brought up, it's interesting that in Puget Sound we've had a artificial production program with yearling Chinook. In some ways, kind of match up with steelhead in terms of the size of the fish, and also matches up in terms of the reduction in survival rates that we've seen. That program was initiated in the 70s to provide benefits to our recreational fisheries. We were getting survival rates of 6 and 7%, about the same as steelhead during that time period. That program is ineffective now because the survival rates for those yearling fish are just about the same as sub-yearlings. So you're spending an additional year of time and money rearing them for basically no benefit. But we have somebody on the panel in the front suggested there's some information there that should help us think about, well, what really is perhaps happening to these steelhead and yearling Chinooks that at least have similarities in size and time as they're moving into Puget Sound. In terms of a missing data item, I didn't see any information presented on the diet of steelhead in Puget Sound. And Puget Sound has just undergone a fundamental change in its structure during the last 30 or 40 years. Species that were once prevalent are gone. Species that were once of limited abundance are now very prevalent. And again, it may suggest that simply pointing back to the seal while a convenient explanation, I'm just not quite. I'd like to see some more information supporting that before I be confident that was the direction we go. There was a question, I think, from Brian about steelhead information. The way I interpreted his question, you see that same survival trend for wild steelhead as for the hatchery steelhead that we've been tracking. And we don't have a lot of information, but where we do have wild steelhead information like that, it matches the pattern very closely. Of course, with that offset of 1 or 2%, it gives better survival rates for wild fish. The pattern is very similar. So just to then set up the next question, we say all the time, is there information developed a model and design phase to represent the Saley Sea? I don't think that's quite the right question. You can always say there's not enough information. My sense is, and this is a really excellent presentation that Ian provided, I think that is the fundamental step that we should be proposing to take now. Yeah.
Just following up on the penalties comments that was made a while ago, and Nick on too. Those programs in South Puget Sound, and Sparks, of course, were a way to relieve the freshwater hatcheries of space limitations. And the idea was to just get them out after a month and a half or so initially. And initially we're getting up to 20% higher contribution. But I think there's an opportunity to go back and use these programs as space is available to do different kinds of release and to investigate how the fish are going to survive. Couple that with the kinds of studies that Scott and other people want to do with water quality and plankton in those areas. But the other thing that was learned in the very early days of the 70s with Cameroon was that the concept that Brian Lee and others had was that we had to put these fish out into a stable environment. And of course, what we've seen subsequently is places like North Scott Bay, where the commercial salmon cages are, by far the best growth and survival are in those cages that vary from 0 to 30 parts per thousand PSU per day, every single day, because of the river going through there. So I was just curious about what you meant about a stressful environment.
And here's asking your question about what you meant about the stressful environment.
The question is we're talking about putting the fish into a stressful environment and it's because it was varying in water quality, temperature, salinity.
I'm sorry, I don't know what the question is.
Okay, well that's fine. Sorry, you were talking about temperature.
I know what you're saying, and I agree with you, and I didn't hear a question, so I didn't say it.
We can maybe talk about that. Okay, Brian, you want to say something?
No, just a question. I forget. And I've known about the delayed release defense for a long time. I can have even use one as an indicator in the early years when it's not effective. But I mean, did you have electricity type, I guess, of Chinook that were resident in Puget Sound, or is this something that people in enhancement decided to create?
For the NEM program?
Yeah, I understand why it was there, but was it a natural life history, and did they exist in that ecosystem?
And during the growth decisions, some of the areas were ruled non-viable stocks. In other words, they've been outplanted with 157 stocks from all over for so long that it was considered the genetic integrity wasn't there. Stockton Sound was one of those areas. And so that you would bring in fish from Quad, from Middle Creek, from even Dungeness. So that was an interesting experiment. We did 5 years of floated wire tag, and then recovered the fish as they came back to the pen, which most of them apparently did, and then put external tags on it and tracked them to where they went. Now, I'm not sure if that was published a long time ago, but it did give us information on the holding and the fidelity of the fish in the pen.
One comment, but the reason that I picked up on what Nate said was because we haven't talked about it, about the natural releases, and of course, in theory, that bypasses that early marine period that we're saving mortality. So, and I thought that's what you were commenting on. I just didn't hear a question on it, but I think it's highly relevant.
I think Josh can answer.
Yeah, I just have 2 comments there. As far as the resident fish being part of the ecosystem before the net pen releases, but I think there's plenty of historic evidence to suggest that there's always been a year-round fishery for Chinook in Puget Sound, well before hatcheries were even a major part of the ecosystem or in the development program. The other thing I would caution is the delayed release of Chinook salmon is mostly focused on holding an ocean typhoid Chinook, which is a sub-year-round fish, for a year longer than they would typically be held. So using that as a comparable might be a little bit difficult because you're messing with not only life history but
That's all I have to watch. We were going to talk about models. Is there something that's critical to follow up on what Josh was saying? Yeah.
I mean, to me, if you have the answer to your own question in that the delayed release of those fish is putting them out into a marine environment where the majority of other salmon have already cleared it of where we can get, and we've got the second bloom from a tipping, so they may be succeeding because they're getting a second bloom where there's nobody competing.
But they're not succeeding. We're talking about the yearling Chinook. Yes, absolutely. Okay. I thought you were talking about yearling Chinook and Puget Sound. Okay.
So that's why I think that's what I'm saying. But they're still entering an environment that's warmer and lower salinity. So even with that additional stress, they're fighting through faster and more of it is actually improving their saliva.
Are they entering at a time where there are a bunch of adult Chinook or adult salmon coming back that can prey for predators that might be around? No. Okay.
Okay.
My question.
I got a question for Dave that could clarify the whole thing, because originally we were told that early entry is beneficial. Like pinks and chums that are going on early in the year are doing better. And a lot of these yearlings are being released in April, so they're not being released in May, they're being held for another year, and that's being released early. But can you clarify, because down there it's late entry, the earlier days, which is it?
Okay, all right.
We should move on.
Is that okay? Okay. So what I would like to know from you guys, I have two microphones, is that is whether or not when you guys think we have enough information to build a model of the Salmon Sea that we can use in the design phase of the research program. I think I'm forgetting now what we talked about yesterday, but someone was saying a model can be very useful to you click it, you plug, I know purpose is not to say plug, but you plug your data into it, and then you can figure out where the gaps are.
Ken Dennis said that.
Ken Dennis said that. I'm funny. Paraphrasing probably. So, is that something that we should be doing? Should we be creating such a model and using that to help guide us? Yes.
So the only question I have is we need the straight folks to look at our data set in Salish Sea and primarily maybe more so Puget Sound and tell us, do we have enough to start that process? That's the only question, because what I heard was that you folks had, at least 30-year data sets, and I don't know if we have that. So, I say we should definitely try it if we have the data once those folks look at it to see if it's possible.
Can you start this? Go for it.
You want to comment?
Well, my view is I could start a model without any data. I think it would benefit other people. 10 years ago, we did an iron fertilization experiment at Station Papa, and 3 months later we had a workshop. And I did a model of how I thought the response of the upper ocean ecosystem would be, without ever seeing anybody's observation. And I presented that at the start of the workshop, and it was very provocative because people liked something, they didn't like something, they wanted to know how I did it, and that is what I think is really valuable. And now people are working on this end-to-end model where they try not to do too much detail anywhere, and I think that kind of model can start to show you where the gaps are in your observations as you try to compare them with observations. So, I would never even accept that that's a valid question to ask. I feel so strongly about it.
Yeah, I just want to support, I think, Jim Scott's observations with respect to where we start. I've actually been very uncomfortable the last 2 days. I feel like I'm being asked questions that I have not put together in a model, if you will. The conceptual model that's in the document is fine. It doesn't really let me get to the decisions that you're asking us to make. And when I do data reduction, I do it by looking at the data and reducing it to a model. You're asking us to make some pretty important decisions here without having done the background work. I really think we have to do some modeling. We don't have to do a 5-year effort to get going. But I do think we have to do some modeling. I do think we have to add the retrospective work on top of it, in comparison to contrast that Mara and others have pointed out. I'm getting older, but I can remember going through my prelims, and I had 2 National Academy members on my committee. And there was no way I could prepare for that. And I went to my advisor and I said, how am I going to do this? He said, just make sure you can answer the questions you won't be embarrassed by. And I'm telling you right now, I can't do that right here. I think there's some questions that we are not tackling that I would be embarrassed to walk away from. But if I get the straight, did Jan Newton say we have no place length data, trend data, and Puget Sound? Is that still embarrassing to anybody? What do we know about food web? I know what the WW approach to food web is. So there's probably somebody better than me here to speak to that. It's embarrassing. You can't make decisions based on that. So I guess I just want to really echo, we got to, I think, go as soon as we get, and I think it's really important.
Ken, could you please clarify, you think we can't make decisions about what? Are you saying decisions about what research to do, or are you saying decisions about what management actions to take?
I think we can use this to make a decision about what research to do.
Okay.
Yeah.
Okay. Yeah.
Okay, we're talking as though there are no models of any sort started for the KLC, and I just wanted to point out that NOAA has some terrific models and ecosystem models, and I've heard the association models on both sides, and I think I've heard some talk about the Georgia models. So I think it's a little bit of a different question of where have we already identified big data gaps from those models, and I know when I first started at UW, NOAA came to me and said, good, we have a zooplankton person finally around here because we have this gigantic hole in our ecosystem model. So we already do have some of those going. We just need to connect the experts together to talk about data gaps.
Thanks for reminding us. And so my confusion about your question, Ken, and about Jim's comment, I just want to say that I think that we need to be, well, with regard to this predation stuff, what I've heard is people jumping to conclusions about what a management action that would be taken if we were to find a significant impact. And I don't think we need to go anywhere close to that at this point. We may want to discuss those, but you can imagine a whole range of outcomes. And so I think there may be, I'm getting a sense that there may be a little bit of confusion in the room about what it is we're trying to accomplish here. What we're trying to accomplish is how do we develop the most cost-effective, most important, 5-year research plan, and then at the end of the week, beyond that monitoring plan, to get at the causes for the decline in sailor survival of salmon and sealet. So that's the goal. And so I'm getting a sense that that's getting lost a little bit, particularly in the concerns about what we would do if we found one result or not.
Thanks, Eric. Good point. Ken, do you want to?
Yeah, just 2 points. One of the reasons I like using models of such as hearing is to not fall into the trap that Darren Kahneman and others have pointed out around the heuristics of decision making. So 30 years of work as a Nobel Prize winner, just anything published book, thinking fast, thinking slow, thinking fast, and so great work. We are falling into that trap right now. We're trying to make some decisions based on the last thing you've heard. That's what we call anchoring. Okay? We're not looking at all the data we have. And one of the ways you prevent yourself from falling into that trap, whether you're making decisions on management or whether you're making decisions about what research to do, is just to look at it systematically. That's all I'm trying to say.
So we agree on that. We agree on that because in this document, in these hypotheses that have been developed, the work that would be done is broken into retrospective analyses, process studies, and monitoring. So I think the retrospective analyses many of those are indicated in here, and we need your input on what, in addition to that, we would include, what types of models we would build. I don't think there's any disagreement about modeling being an important component of developing the 3 plan. So we agree.
All right. I see Alan, and then I would like to ask a question. Julie mentioned that there are existing models that we can use. What are they?
I guess from what I've heard, maybe the first 6 months could be take a break, get the data organized, and then think about it a little bit more in detail. But people have been talking about the standardization of data, and that seems to be the highest priority. Get the data we've got, put it into a shape that's comparable, and come up with some conclusions to that effect.
Scott, do you want to?
So what I'm hearing here from Jim and Ken and others is this isn't the right question. You have enough information to develop a model in the design phase. I think the question is, would it be helpful to develop or organize or modify our existing models in the design phase, and that would help us to have a finer point when we develop a research plan, or as we develop a research plan. Is that what you're saying, Ken?
Right now we have
maybe two compression, but I believe right now we have an ecopath or ecosystem model for the South Sound that was done about 10 years ago, and then we have NOAA's Chris Harvey's food web model, which is a much better, much sophisticated model for the ecosystem, but for the central Puget Sound, but we're essentially saying it very well, Puget Sound. It's a great place to start. It's only one model. I think several people pointed out earlier that one model isn't good enough, but we need to triangulate probably around a couple of models. I think Ian presented that. But we haven't asked that model yet. For example, can we ask that model what our research priorities are? Can we use Chris's model to say, and I know what data he has in there, but we can play with that. Can we not use that to inform what we're doing here? Have we tried to do that? I mean, that's just one potential option, I think.
I can answer the question, yes. We tried to get Chris Harvey on the technical team last year, and he was too busy. So there's one. Okay, so you tell him to come over, and we'll play.
So I guess my suggestion is that's helpful, and the models that I'm aware of can help us. They're like the ecopath model. They can help us to look at the interrelationships within the blanking community and the food web in general, and how it relates to some physical processes. One of the first questions that was asked here was, are there management measures, or is there a feasibility of management measures that can drive our research so we don't spend time and money working on things that we can't control? So I don't want, those are maybe not mutually exclusive. I would submit that the ecopath is perhaps, whatever models we currently have are not written to drive us to or connect directly to management measures. So if that's the case, if we really want to answer that first question, and the folks in this room think that's a helpful question to ask, then we need to create new modules on the existing models, or completely new models that are complementary with our existing models that we can modify. But I will agree with both you and Jim that, and I think I brought this up yesterday, or earlier today, that I think this modeling is a terrific first exercise, along with data archiving and data analysis, and that we have queued up some hypotheses that will allow us to more powerfully interact with models we do have and we don't have yet.
Dave is going to speak and then...
Okay, yeah, I'm the guy who built that 10 years ago, the South Puget Sound model, with the help of Andy Rangis, and for the past 3 years I've been working with Dick and Chris and Rusty on putting together the model of the state of Georgia. And next year I'm going to be starting with the Pacific Shellfish Institute to build an ecosystem model for them, which is going to be used to investigate farming questions there. As to the point of whether or not there is material that's come out of that which is useful to this question, the answer is yes. The poster I presented here was directly related to that. One of the emergent questions that comes out of this modeling work, which is right now in the state of Georgia, is used to simulate what happened between 1960 and the present to see if we can reconstruct changes in the species that we've been monitoring pretty closely. And we're able to do that, but with the caveat that the model is incredibly sensitive to a couple of things. And this is what I suggest for some of the research priorities you should move forward with, which is some of the points we've touched on. One is, what are marine animals eating? What are the competitors and predators of Chinook and Coho doing? That's one thing that comes out of there. The model is incredibly sensitive to those assumptions.
We know that that's probably important, but we can't say precisely how. So that's one. The second thing is, and this will probably be exactly the same result as the sound model, we are not anchoring those models with any really meaningful bottom-up mechanism. We know we can manipulate it to reproduce history using bottom-up forcing, but we don't have the resolution to say what that is. Is it timing? Is it amount? Is it food quality? So that's where we're at. So I think that, if you want to, what I can say is useful recommendation for research, is resolving that issue with the next step of modeling, which is anchoring it with the bottom-up information to limit the system and to start addressing those field research programs, which are going to give us useful data to be able to make predictions on what the trade-offs are between competitors and predators on the system that's going to develop.
Great. Thank you. And then Julie, I wanted to ask you, what model did you study?
The ecopathy.
I was on.
I just actually, I'm not a modeler, I'm not a.
Okay.
Well, Dave just talked about coupling to a bottom-up model, so that's the kind of models I'm familiar with, the plant and food web. And in 1990, Mike Fashion from the UK basically published the first modern planktonic food web model, and most of the others have been based on that. And he said very strongly in that paper, we just don't know enough about the zooplankton. And I just reviewed a NSF proposal Sunday morning before I came here. People are talking about end-to-end models, a couple of the physical models, and they said, we just don't know enough about the zooplankton. So those models, they get up to the zooplankton, and they have major problems going any further because there's not enough information. And, Ian did this Bayesian type of model to look at what factors are the most important. And if you remember this morning, the two factors were zooplankton biomass anomaly and copepod biomass. So, if I were doing this, the very first thing I would do would be to put together a simple stage model for the major zooplankton species, because this mismatch thing, if you just have zooplankton as a box, that's not enough. And that seems to be how we can't couple to the upper trophic ecosystem models and the other one that was in the NOAA. I think that's the real, and so that's where I would start. But because you could take these ecosystem models and you look at all the fluxes. And some things people will look at this and they think, how do you know that that is that? And that's where you start. You start eliminating the fluxes that don't have anything, and then other ones you just don't trust. And that's where you start doing the observational stuff. Do we know enough about this? And so, to me, I can see how I would go forward, but, there's a wonderful physical circulation model that Parker has. They've started putting together the lower food web. They're up to the zooplankton, and the next step is to start, I think, enriching the zooplankton level of this model.
If you can answer that.
Yes, there's at least 3 groups that have working circulation of MQDD models, MQDD models, pretty heavily tested against data. There's one called PNNL and another effort at University of Washington. Any of them would probably have to be, move forward a little bit more to be relevant to this. But they're very much technically useful with really highly, resolved in space and time, and really realistic contact models. So there's other layer of information that's useful for planning.
So we're now at the stage where we're at the risk of everybody, what's your favorite model? And I want to put a plug for what I want to follow up. So I've got the microphone. I can do this first. I just want to follow up on a Ken's comment quickly for the plug for the Bayesian network models. It's something we work with quite a bit. They're very popular. They've been well developed in Europe, but they haven't really gotten to North America yet. They can include management systems. So you can actually have a decision model built into a Bayesian network model. What we've used them for is for structuring the data that we have. They've been used paper in nature for climate change predictions and polar bears, for example. So they can do quite a lot of things. I've come to understand they're quite difficult to build, but once built, they can be handed off to your grandmother and she can use it. It can be quite easy to use.
Anything else on models? Or see, Ramona, hang on. Is there anyone else who wants to say Dave? Okay. Oh, and Dave. Okay.
Some of the data gaps for some of the models that I've seen coming out of some of the sea level rise workshops that we've launched in the past few years is some of the information on what we're going to be losing in a prey-based situation. Because of sea level rise, basically, we actually are shoreline. And something that I'm verified that we don't have in British Columbia is a map of the beaches that are used by some of the very, very important sea fish, salmon, and surf mills. So we don't want to model the effect of something like sea level rise on the prey availability for the salmon, not having the data on the field, from the field level, of what beaches are being used in British Columbia, number one to me is appalling and embarrassing. So I've been sitting here for a couple of days wondering when people are going to start mouthing non-herring forage fish issues. And I think I've said it a few times. But when we do models like this, and we look at what management outcomes are, and what the decisions are, if we don't have some of these other data sets, I really think that we're kind of missing the boat.
Okay, just one last thing about the modeling. It's good to hear what Parker is saying about that sort of work that can be extended on. But there is always one caveat that needs to be added, and one of the reasons why it's historically been challenging for the upper trophic level guys and lower trophic level guys to get together is an issue of it's the issue of resolution, spatial and temporal resolution, right? The ecopath, ecosim are these box models which operate on time steps of months, usually in some cases annually, right? So that's the one thing to remember is that part of the reason this hasn't been done very successfully before is because two traditions have been hesitant to find ways to have a handshake to marry up those two data sets. So if there is something like that which is going to happen, it's something for all of us to keep in mind. We have to make sure we have a way to convert currencies between the two traditions.
So I think we were showing some examples of what I would call more tactical level models through the course of the workshop here that look at some of these temperature tennis effects and quantifying the potential for predation or competition, et cetera. What I'm hearing from the ecosim type models are there's a lack of good those types of data. From the physical models, again, we don't know much about zooplankton. The emerging theme throughout it is that we don't have empirical information on zooplankton. So I guess the challenge here is what are we waiting for? We need that information, and we need it methodically in a monitoring program, and we need that in concurrence concurrently with a number of these other things that are going on. So I would hate to see if we would defer any further data collection in favor of stopping and constructing more models on top of what the collection models have already seen.
Great. Thanks. Okay.
Well, when people talk about zooplankton, are you including ichthyoplankton? Or are we just going right by that?
We're going right by it?
Are we going right by it?
Yes.
And that, so, I mean, clearly that's got to be a link in there because we already said salmon don't eat copepods. So, I don't think we have any more data on ichthyoplankton. It's probably our worst set of data in Canada. So, let's just make sure that's included.
Okay. So we have about 25 minutes left. Most of the questions that are there. Mara and Sophie and others have offered some ideas about what must be done simultaneously and what can be done iteratively. So I want to take 5 or 6 minutes. Anyone else want to offer any thoughts on things we can do iteratively or that we should do simultaneously? Mike.
I just want to point out that the last 2 days here this week, we're trying to develop applied management forecast tool, monitoring plan for that. And there's 100% overlap between that and this project. I would say there's a lot more in this overall research effort than there is within that. But everything that's included in that is part of this program. So in the end, the idea there was to start developing something now with an applied management focus in forecasting that would essentially be a tool that would be informed by developments in this project, but that wouldn't sit around any longer because we already are lacking any sort of environmental-based forecast tool for Puget Sound. And we've seen it useful out on the coast, but we haven't been able to apply that data to Puget Sound stock that hasn't held up. And it's occurred to us that we've seen big differences in survival in sub-regionally within Puget Sound if we had had that data, that type of a tool. So I'm just saying in the end that I wish Ken was here right now to answer this, but it's great to have a tool, a model in place that would help inform our decision making. But the thinking there was we're going to start with what our best estimate is here with this group to get our best step forward right now and what a forecast tool would look like now and start to develop a systematic monitoring plan that we would, have to inevitably revise as we learn more about it. Bill talked about how sub-regions, you might take 3 out of 50 samples to get some fish for one thing, and that the areas that we usually pick aren't all going to be perfect, etc. That plan is going to get adaptively managed, but to take a step forward now and do something is already years late. So
what is it that we should do? It should be done simultaneously or iteratively. Anyone have a thought on that or should I move on?
Just one last comment maybe on what must be done simultaneously. I think all the work being done on the salmon stock, we should be collecting DNA data on all of those samples. And start looking at these across other things and try to tease apart some of the noise we get between different responses to the various climate and environmental problems.
Any other updates you want to discuss?
It's happening right now in the state of Georgia with the 12 survey program, and Ed referred to it in his presentation on what's going on in Variant City. And that's what Dave was talking about, is going out and collecting that zooplankton data with the fish data, because ultimately that's going to have to be where we're going to find the answers. Okay.
Great. All right.
I guess the thought that just when you said that, I don't know that trawling is, we should continue it. It's probably one of the only time periods, but let's at least keep open to smaller vessels, more locations, near shore. We've got all sorts of boats in Canada that aren't being used because of the state of fisheries. Right? A little bit of money directed to communities. You could probably have a dozen boats out sampling, getting huge coverage that we cannot do in the near shore. Right? We could also have different trawls. Right? We use the Norwegian live practice trawl.
Amen.
on that. So, I mean, let's not just think in terms of we need the big vessel in the middle of the strait.
No, you missed what I was saying.
No, you missed what I'm saying.
That's a fair
Okay.
Christy, and then we're going to be done here. Okay, Christy, and then, yeah, and then we have about 20 minutes left, and we have
Just quickly, in addition to collecting just for DNA, you should be collecting fish, and if that costs freezers, minus 80 freezers, I mean, there's nothing better than an archive of fish to go back to, even years ahead as technologies change, and begin to assess, multiple years of information. The problem is that to start anything new, if you don't have a backup of samples to go back to, you can never get those long-term data series, and we don't really know where things are going to take us. So right now we have a lot of technologies that can be used if we have fish samples, and frozen fish works for a lot of us. Okay?
So my thought in answering Mike's question is that we can do both iteratively and sequentially what we need to do in the next workshop, which is to start developing a management tool to help us with forecasting. I think it's a matter of scale and coarseness. So we may only be able to take what Ian has given us for the Strait of Georgia as the starting point for the variable that we're going to incorporate in our model. It'll be coarse. It's only going to flow at high levels in terms of fish, but it'll be an improvement over what we have. In the meantime, while this group is drilling down into more detailed modeling and understanding of the bigger ecosystem.
I want to go back to what Ryan said, because I agree 100% that we need to be scouting in the near-shore areas. And going back to what Dave said, we are taking DNA, and I know in our surveys in the State of Georgia, both our standard trawl surveys and the purseine surveys that we've been doing, looking at interaction with aquifer, with salmon farms, we have no less than 4 different labs taking samples and acquiring tissues from those. So, I mean, that's a good step. And sampling those fish as they come out of the river before we sample them in the ocean, so we know the condition before and after on what's going on. But we have to be innovative in how we get those samples, and we're looking at a smaller version of the trawl. I don't think that's going to be satisfactory. Maybe going back to that 4x4 trawl we used way back in the 80s. Purseines are great, but they have some problems as well as with what we're seeing in those purseines in comparison to what we're seeing in the trawl. But we have to get more creative in the near-shore area.
Great. All right.
So right now for management, we're using. Right now for management, we're pre-season forecasting. We're taking full up and trying to apply some kind of marine survival based upon data taken off the Washington and Oregon coast that isn't, as Mike pointed out, hasn't worked out for Puget Sound. The alternative is to use average run size, and then we're always wrong. But what we've heard during these couple of days is that there are data sets out there that in Puget Sound, the South Puget Sound, that folks don't know about and haven't been sharing back and forth. Well, we have known that Jan Newton and company have been doing various gathering data for productivity and throughout Puget Sound. That's a place to start, just sharing that data set with the folks that are doing forecasting to see if we can get some kind of a productivity index. And do some hindcasting with it, see how that would work. There are things we can start with just by sharing the data, letting each other know what data we have and what data we need. Set up some kind of a system for communication between this group, between managers, forecasters, and different researchers.
Great. Alan, if you need more something, then I want to talk about some.
I was just going to mention the Andy and repeat the commercial that somebody made about the Marine Water Summary for 2011, which covers basically all the data that's been collected in Puget Sound by anybody who knows about it. And it's modeled after the State of the Ocean report or the PACOS report. And it's a start. If you see something that needs to be added, let us know or participate in the work group.
Okay. So I would like to ask what in about 7 minutes, whether anybody has input about, I mean, we have 7 minutes left approximately for this question. Input on how we evaluate cumulative effects. This is a huge question. But does anyone have thoughts for us that we can take forward?
This is a simple answer, just modeling, and yes, okay.
Yes. Okay, move on. All right. So then,
Well, I guess there are two. Maybe a specific question would be, are there any examples of cumulative effects modeling that anybody's done? Greg, I thought you did something recently with, am I wrong? I thought we had a publication recently that was cumulative effects. Yeah.
Sort of the random even Bridget Horner type approach that we looked at. Brendan Connors did the modeling and the hierarchical type of approach to look at.
louder, please. We can't hear you.
So Brian basically looked at using hierarchical type modeling approach to look at relationship between productivity of 16 glacier stockade stock and Cape salmon, salmon farming, and coastal position. We're currently using that same approach to look at it in more detail with Cape salmon, looking at the effects of things on stockeye length and age and bigger activation. That involves 24 stock. Data going back to 50 years. Washington,
Okay. Great. All right, Jackson.
Yeah, I'm going to check for Paul Hertzberger has a lead. He said to me on his way out that he felt that in addition to models, there were some microcosm, both laboratory and field microcosm replacement experiments that we could look at cumulative effects by controlling different parameters and sort of adding stressors or taking away food resources or changing temperature, et cetera, in areas where we really didn't have enough information to model them effectively. So that's just another way to get at this.
The work that I've done suggests that to get a cumulative effect, you need a large sample size. You can do some modeling for sure. You can do experiments. So in the natural world, you want to be able to test those. And in that sense, you need, in the time course that we're talking about, I think we need to think about a broad spatial pattern of data.
Any thoughts on that? Okay.
But it's more than just modeling. Cumulative effect means you have to actually sample some other things. And there's a lot of fish, certainly in the various sources, that we pay no attention to, and they're extremely abundant. And you know, how are you going to deal with their glosses or nyctophis or slender sole or pollock, even dogfish? You know, that's where there's a commercial fishery. You don't have a good assessment for dogfish. So these major species that some are obviously competitors and some are predators, and we're paying no attention to them. So how are you going to model without having that information?
All right, good point. Other thoughts on that? No? Okay, then let's move to standard.
Sorry, rockfish.
Rockfish.
Right?
What? Real quickly. Okay, so real quickly, any thoughts on standardizing and consolidating data?
Yes.
I guess we should do that.
Very good.
Better do it. Better do it fast.
Next.
What's next? All right. We also have maintaining cross-boundary communication.
Telephone, yeah.
Cell phone, email is what those are.
So as Castillo was saying earlier on, a bunch of BFO, NOAA scientists, university colleagues have met almost every year since 1998 at the Salmon Ocean Ecology meeting. So next year we're not having it per se because the North Pacific and Pacific Commission is organizing one in Honolulu, but after that's going to resume back in Victoria in 2014. And it's probably just a question of making sure that participants that are here that are interested in hearing this are on that mailing list so that we make sure that we reach them to come to this meeting, because it's been very informative in terms of what we're seeing up and down the coast in terms of what might be the drivers of salmon productivity.
On the same line, there's a meeting in September every year called East Pacific Ocean Conference. There's a meeting every September called East Pacific Ocean Conference, which is mostly ocean ministers working in California current. And it's a nice meeting, 60, 70 people. We don't want a lot more people. But it's really a good meeting because learning what's going on in California current is ocean records. I mean, physical oceanography, biological oceanography. We talk about fish sometimes. But it's like a salmon meeting. It's very informal, and you meet new people, and I mean, great contact. Highly recommend it. For a few people coming.
Any other thoughts on that? All right. We need to talk about integration with regional initiatives. Probably not. Okay. Do you want to say anything about integrating with regional initiatives?
Well, our program hopefully is going to continue. We're kind of negotiating that right now, but we've got to get more involved with you guys. Because we're getting the ocean data, and it's just to get the ocean eventually. Some of them never do, but some do. And we need to understand more about that, and we need to be involved. So.
Great. Anything else? No? All right. Then I think I will close the discussion session. There were instructions provided to you in your package about how to send additional feedback. I believe it all goes to Mike. Is that right? So email Michael Smith@llpk.org if anything occurs to you tonight, tomorrow, whenever. Comments before 7:30 p.m.
Well, today
would be most useful because then we can feed them into tomorrow's discussion with the organization.
But it doesn't have to be that way. You can do it in a week. So
Michael, will you recap the ranking the day conference with Thursday, Friday?
Yes.
Okay, great. How are the recommendations tomorrow?
Well, I'll try to summarize what happens tomorrow for Thursday, for Thursday's meeting, and how we'll carry the information over. The outcome, I don't know, conference with you overall.
Corey can maybe say from there. Right up here, Rob.
So I think we're for Thursday and Friday session, there's going to be a lot of overlapping topics, and a lot of the conclusions will be very similar. And so we've got members on both. There's going to be plenty of communication to allow us to move forward on both in a smart fashion.
Great. Okay. All right, now let's just turn it back over to Brian Riddell, who will give us some concluding remarks.
As I'm scrolling them down before I say them. Well, obviously, lots to think about. Advisory panel tomorrow. I'm sure we had a lot of this stuff
obviously, I want to thank you all for participating. A few questions actually still hang in my mind in that. And early on, I guess I said, Mike, one of the fundamental questions in my mind is there sufficient benefit in having a bigger group? So is there really value in this large-scale collaboration across an international boundary? There are reasons why it hasn't been done. It does interject different issues and that, and so I think we really do need to decide if we make a commitment to proceed. And is there sufficient benefit in trying to actually integrate a program across the boundary? And we could simply go ahead and do our own thing the way we've been doing. We're still going to go ahead, and I have a funding plan in mind on how to do the Canadian side. I think that's right. I probably don't have enough money, but I'll get more. Well, if we're going ahead, yeah. Well, that's your opinion. I haven't heard anything that really convinces me. Actually, I don't agree. You'll end up with two maybe large-scale programs that for particular areas of the Sailor Sea. The Sailor Sea... I'm not asking myself, I'm asking everybody.
I mean, one of the examples that was, clearly give you justification for that information would be the toxicology. So, I mean, you folks are sitting in a 3.5 where the U.S. component of the integrated group might be able to lend expertise in the system. So, there's one example where in return we might get help from Ian to see clearly that Spring of Georgia, my project, is way farther along than we are in town. So, we need that. The benefit of integration is sharing resources.
I mean, I started this thing with Mike, so, I mean, you know my position. I think there is. But I want to know that you're committed that if we move this forward, that we're going to do this. Right? Because if I go out and get $10, $15 million or help people do this, I'm going to wear this if it just falls apart. Brandon Cliff at UVic said I'm an idiot. Right? How are you at herding cats? Right? So, I mean, do we really want to jump into this? Are we committed to doing it?
I mean, I think the commitment is how well we come up with our chunk.
Yeah, that's certainly a message. So, Alan?
What's better be turning on? As actually a person in the southern state of Georgia, it has to be coordinated. Because our Chinook are living up in your area. There's a hypothesis that our herring are dead because Calmanus pluncus is no longer around. And you just mentioned the Ulicans and whether or not the sea lions ate all the Ulicans, I don't know. But
we know that.
Get away from us. So if we had to go one way or the other, we would probably coordinate more with your approach.
Well, I mean, one of the obvious things from my perspective is I have no idea if I'm actually a Canadian commissioner anymore, but if I get back to that position, then I know that certain commissioners on the U.S. side are fully in favor of using commission funds to do unique things like this collaboration. Right? And so we do have an opportunity, but you will not get those funds if you don't have strong buy-in on both sides. Right? And so it's one of the payoffs you can have. Okay, so I will assume that we are moving forward, and then it's a matter of how we do this. I mean, we've talked about various exercises. I'm not sure that I really think that there's enough uncertainty about let's go ahead and do the biological model or the oceanographic modeling. A lot of it's done. Integrate it with the biological processes. Get the standardized monitoring in place. Isabel and I have funding for 2 more years through UBC. It's a family foundation, and the money is definitely secure. And that if we move forward as a data center to provide standardized data for everybody in the Sailor Sea program, I think UBC would be probably excited to do that. I can't speak for them, but Andrew's here. And we've had nothing but fabulous support with that school. And they have very bold ideas. They're talking about a UBC cloud, where everything that goes in under our group would be free to users. Right? So you really do have opportunities where we can truly have free access to information. And so that's another opportunity we have down the road. And yeah, that's probably fine. I guess the last point is I think that I really wouldn't want to see us put off a full year. I don't want to get into saying that we have to wait for all sorts of models. We should look at some sort of strategic movement forward because there are just too many opportunities coming up in the next short term that we may simply not get to if we don't do something. Colon will be implemented in some way. There will be opportunities. Things are going to happen in the Strait of Georgia. For example, the Salmon Treaty has been on hold for 3 years because the next chapter that needs to be renegotiated is the Fraser sockeye tank. And Mike's the chief biologist for this, so I'm sure he's looking forward to this winter. And that. But I don't think that there's actually big issues. I think the two countries have already got a plan to move forward, but it's definitely going to tie into the Cohen Commission. So there will be pressures to move forward, particularly on a couple of the big recommendations that I emphasized in terms of marine survival studies. So I think we really do have an opportunity. I would be concerned if we simply put everything off for a year while we build a model we all agreed on. So I think we need to think about a phased sort of program, and I'll certainly bring that up with the advisory committee tomorrow. I just say in closing that, any thought you have, if you're not participating in the advisory committee, just send them on anytime. If we don't have them tonight, just keep signing up. Because there's going to be lots of future discussion going on. And I guess the last thing is to thank the email king for all his efforts. And Lori, for you and your staff have been wonderful. And I actually can't even think of a workshop I've gone to where we've actually stayed on time like this for 2 full days. So I think that's an accomplishment in itself. And so thanks very much for coming, and we'll get together soon again, hopefully.